Hello everyone. Today I'm going to show you how to do the binomial distribution in Excel and in the calculator. When you're doing your binomial distribution, we have 5 different scenarios. The first scenario, you're looking for when the probability is exactly at a certain value. Scenario 2 is when your probability is less than or equal. Third scenario is when the probability is less than. Fourth scenario is when you're looking for the probability greater than or equal. And then the last scenario is when your probability is just greater. Underneath the scenarios here is the formula if you're writing out the formula by hand. This block down here shows us other words that are used for each symbol. So if you're using less than, another word you can use is fewer than. Greater than, you can use the words more than or exceeds. Less than or equal, you can use no more than, at most. Greater than equal, you can use the words no less than or at least. These are not the only words that describe these symbols, but those are the most common. This other picture I have here is the steps we use to type in the calculator. We will also be using these similar steps in Excel. So if you have exact, if you're looking for when your X value is exactly this number, you'll be using a binomial PDF in the calculator. And PDF means it's not a cumulative, it's just that particular value. We have when X is less than or equal a certain value, then you use the binomial CDF for cumulative. If we have X is greater than or equal to some value, you have to do the complement, which is 1 minus the binomial CDF. So you're doing 1 minus the accumulative probability. And when you do this method, make sure you subtract 1 from the known value. If you have a X less than some value, then you're using the accumulative distribution again for binomial. And again, make sure you subtract 1. And then if you have a probability of some X value greater than, you would also do the complement, 1 minus the binomial cumulative distribution. And then you type in your numbers. N represents the number of trials. And then we have the K value, which is a number. That K value is the number of successes. And the P value is the probability of that success. All right, so let's go ahead and begin. So when you understand accumulative means you start at that number and you add up everything less than that. So for example, if I have cumulative for X less than or equal to 3, when we use the accumulative distribution, we're including 0, 1, 2, and 3. If we are doing X greater than 3, then we would have to do the accumulative of 1 minus everything less than 3, which will be 0, 1, 2, and 3. So make sure you subtract those probabilities of each of those numbers. So that's why we do the complement. Same thing with X greater than or equal to 3. We're going to do the complement. We're going to subtract everything that's less than 3. So in this case, we'll do 1 minus the probability 0, 1, and 2. Since 3 was included here, it was greater than equal. Then we're going to take everything less than that, which is 0, 1, and 2. Versus this greater than, you'd have to take that 3 out as well, because greater than 3 means you're starting at 4. So that's a little background. Hopefully that made sense. So let's go ahead and do Excel formulas first. And then I'll jump in and show you how to do it in the calculator at the same time. So the question says, if you have X is a binomial random variable, they want to calculate the probability of X for each of the cases. So A says we have an N value of 4. So that's the number of trials. X is equal to 1. That's the number of successes. And the p-value is 0.3. So when you're using Excel, you're going to click an empty cell, go to Formulas, More Functions, Statistical, use the binomial distribution here. It says number S is the number of successes, which was 1. Trials was the N value 4. The probability of success was given as 0.3. And then we need to determine, excuse me, whether or not this is considered an accumulative distribution. In this case, since we're looking for an exact value, this is not a cumulative distribution, so we type false. And if you look at this table, there's only one that is not a cumulative, which is the exact value. Everything else has this CDF, which is the cumulative. So the only time you'll use false is if you're looking for an exact probability. Everything else uses a cumulative, so you'll be using true for a cumulative. But we're only looking for exact for this particular question. So we input all the values, type in false, press OK, and there's your probability. To do it in the calculator, you turn it on, you go to second vars, scroll up, just like it says, binomial PDF. So binomial PDF is option A, press enter. My calculator is updated. It tells me which one is which. If yours is not, then you just follow the order that it shows you, binomial PDF. You type in the N number, comma, P, comma, K, and the comma can be found next to your parentheses. But mine's updated. We just fill it in. Trials was the N value. So we had 4. Your P value was 0.3. X value is 1. Paste it. And as you can see, this probability matches the one in Excel. Part B says N is 9, X less than or equal to 3, and the p-value of success is 0.2. So X less than 3. We're going to go to the table down here. X less than 3, it says you need the binomial cumulative. So that means we need true when we use Excel. So formulas, more functions, statistical, binomial distribution. Number of successes, we need the value they gave us. It says we need the K value. In this case, our K value was 3. It said X less than or equal to 3. That's the K value. Number of trials was 9. The probability of success was 0.2. And yes, this is a cumulative because it was X less than or equal to 3. We type in true. We'll check this in the calculator. Second vars. X less than or equal is the binomial CDF in PK. So we need option B, binomial CDF. Trials is N. The p-value was 0.2. and the K value, in this case, the X value was 3. Paste. And due to rounding, we'll stop at 8. So they both match at 0.9, 14, 35, 8. For option C, it says the N value is 10, X is less than 5, and the P value is 0.65. So X less than 5. You go down to this table. X less than 5, you need the binomial cumulative distribution NPK minus 1. So instead of using 5, we'll type 5 minus 1. So formulas, more functions, statistical, binomial distribution. So 5 minus 1 is our trials, is our number of successes. Our trials was 10. The probability of success was 0.65. And this is a cumulative, so we use true. We'll check this in the calculator. Second verse. So let's check again. It said option C, X less than 5. So we go to the table. X less than a number, you need the binomial CDF, which is option B. And then it says you need NPK minus 1. So N is 10. The P value was 0.65. And then you do the K value minus 1. Paste it. And they do match 0.094934 if you round. Option D. N value is 20. We have the X value is greater than or equal to 12. The P value is 0.7. So go to the table. X is greater than or equal to a number. You have to do 1 minus the binomial cumulative distribution NPK minus 1. So we'll do this in 2 parts. We'll find the binomial cumulative distribution first, then we'll go back and subtract it from 1. So we'll go more functions, statistical, binomial distribution. Okay, so it was greater than equal. So at greater than equal, we needed K minus 1. So we need 12 minus 1. Our trials were 20. That's the N value. The probability of success was 0.7. And this is a cumulative because it said CDF. And then we need to do equal 1 minus that probability. So this is our answer. This first answer refers to the probability that the X values are less than 12. And this answer was what we were looking for, the probability that X was greater than or equal to 12. So we kind of got 2 answers within this one question. All right, so let's do it in the calculator. So again, we'll look at D. It says X is greater than or equal to 12. So we go to that on the table. X is greater than or equal. It says you can just type it in as 1 minus. So 1 minus the binomial cumulative distribution. So second verse, go up to binomial CDF. It says NPK minus 1. So 20, 0.7, K minus 1. And as you can see, the final answer matches on both. I did not do it in 2 steps in the calculator. You can if you want to, but it wasn't necessary. The calculator will do it in 1 step. If you're using it in Excel, break it down into 2 steps. The E, part E. It says your n value is 7, x is greater than 5, the p-value is equal to 0.5. So x greater than 5, go to the table. Greater than is at the very end. It says we need 1 minus the binomial cumulative distribution of NPK. We don't have to subtract anything from the K value. So we'll go to formulas, more functions, statistical binomial distribution. So our K value was 5. Trials was the N value. Probability of success was 0.5. This is a cumulative distribution, true. Now we have to do the 1 minus because that's what the formula shows. So 1 minus the previous answer. So again, this answer here gives you the probability of x less than equal 5. And then the answer we actually wanted was the probability x greater than 5. So we'll check this answer in the calculator. So this is the answer we wanted. So we'll pull up the calculator. So again, we have x greater than 5. So go to greater. It says you do 1 minus. So 1 minus binomial cumulative distribution. So second vars, go up to binomial CDF, press enter, and then the N value, the P value, and then the K value. Paste it, and there you go. 5 scenarios. This table is going to be your friend. It shows you the breakdown of each concept. They may not break it down into basic terms like I have here, where it actually tells you N is 4, X is 1, P is 0.3. Some cases they will give you a paragraph and you have to identify what your N value is, what your X value is, whether or not you're less than. It will specify whether or not you're greater than, and then it will tell you the probability of success. In the beginning, it might lay it out for you, but as you move on in the chapter, it wants you to write out those from the paragraph that they provided. Okay, but it doesn't matter if you do it in Excel or by the calculator, the results will come out the same.